going to do lesson 3.7, which is solving ax plus b is less than c, an inequality. Lessons 3.1 through 3.5 had to do with equalities. Lessons 3.6 and 3.7 had to do with inequalities, but you'll see that many of the properties in 3.1 through 3.5 apply to inequalities as well. There are a couple of special situations, and we'll point those out when they come up. So the big idea of 3.6 is that ax plus b is less than c can be solved in 2 steps, very similarly to what you saw with ax plus b is equal to c. The homework is, once you've watched the video and listened to the video and taken notes, go ahead and read 3.6 if you're comfortable with what you've seen in the video. If you're not, wait until after we've had a brief discussion in class and read it after that, so that you make the most efficient use of your time. After you've had the video and read the text, we're going to do practice work in class, and it's going to be one of these 2 things depending on what I assign to you. But that will occur in class. Okay, the first thing that they talk about in lesson 3.7 is the addition property of inequality. And if I have real numbers a, b, and c, and I have an inequality of a is less than b, then if I add c to both sides of that inequality, I maintain what they call the sense of the inequality. If I started out with this symbol and I add c to both sides, I still have this symbol. If I started out with this symbol, the greater than symbol, and I add c to both sides, I still have, when I'm done, a greater than inequality. So I have a bunch of examples of this here. We're using 2 positive numbers, a negative and a positive number, and 2 negative numbers. And you can see, regardless of the situation, if I add 3 to both sides, and it's 2 positive numbers, I still end up with the same sense of the inequality. This inequality at the beginning and end does not change. And that's true if I have a negative and a positive number. It's also true if I have 2 negative numbers. Adding a 3 to both sides does not change the sense of the inequality. It does not flip the inequality symbol. So that was adding a 3 to both sides. Well, what if I add a negative 3 to both sides? Well, that's the same thing. Adding 3 is the same thing, or subtracting, if I add a negative 3 to both sides. I'm still adding something to both sides. So if I have 5 is less than 6 and I add a negative 3 to both sides, I get 2 is less than 3. Okay, I've added a negative 3 to both sides. 2 is less than 3 is true. If I have negative 4 is less than 2, which is true, and I add a negative 3 to both sides, I get negative 7 is less than 1. Also true. And the inequality symbol does not flip. If I have negative 8 is less than negative 7, and I add a negative 3 to both sides, I have negative 11 is less than negative 10, and that's also true. So adding a number to both sides, whether it's a positive number or a negative number, does not change the sense of the inequality. The time that the sense of the inequality changes is with multiplication, and I put this property here, even though it was from the prior lesson, just to remind you what it is, because we're going to use this in this lesson. Part 1 of the multiplication property of inequality says, if I have x and y, and I have a number a, and that number a is positive, and I multiply both sides of that inequality by that positive number, the sense of the inequality does not change. If I started out with this inequality symbol, after I multiply both sides by a, I still have that inequality symbol. However, if I multiply both sides of this inequality, x is less than y, by a negative number, the sense of the inequality changes. Ax becomes greater than ay. So this less than inequality becomes a greater than inequality. And we're going to practice that several times in this lesson. So here let's do the solving inequalities first that have a positive coefficient. So when we had a as a positive number, okay, like in this case 0.3 is our a. So we're going to solve this inequality. First we ask ourselves, is it in the correct form? And yes, it is. Ax plus b is greater than or equal to c. With a is 0.3, b is 7, and c is 70. So the first thing we're going to do is get rid of b, okay? And we do that by adding a -7 to both sides. That's the addition property of inequalities. Okay? And when we add a -7 to both sides, we get 0.3 is greater than or equal to 63 when we simplify. So now we want to get rid of a, and a is 0.3. Well, a, as we said, is a positive coefficient. That's what this is practicing. So we multiply both sides by 1 over 0.3. And on the left-hand side, the coefficient goes away. And on the right-hand side, we have 63 divided by 0.3 gives me 210. That was using the multiplication property of inequality, part 1, using a positive coefficient for a. Okay, so that's our answer. N is greater than or equal to 210. Well, anytime you have an inequality, you need to check it twice. You need to check it for the greater than part of the inequality, and you need to check it for the equal part of the inequality. So first let's start with the equal part. So let's substitute 210 into the original equation. 0.3 and plus 7 is greater than or equal to 70. Put 210 in there and you get 0.3 times 210 is 63, and 63 plus 7 is 70. And 70 is greater than or equal to 70. So it does check. The 210 part of it checks. Now we've got to do the second part of the check. So that was step 1. And we've got to do step 2, which is to check the greater than part of our solution. So pick a number that makes it true, that's easy to work with. And I picked 250 because that's easy to work with. 0.3 times 250 plus 7 is greater than or equal to 70. 0.3 times 250 is 75. 75 plus 7 is 82. 82 is greater than or equal to 70. Check, that does work. So we were fine in this whole problem, and we did not flip the inequality symbol because it was a positive a. All right, so let's try a couple of these things with the multiplication property of inequality from lesson 3.6. But I want to show you how it applies to division, because as you've probably recognized that dividing by a number is the same thing as multiplying by its reciprocal. So even though they call this the multiplication property of inequality, it applies to division as well. So let's take a positive a and do the multiplying, and that one we'll do pretty quickly because we've already tried that. But then we're going to do the dividing. So 4x is less than 8. Multiply both sides by the reciprocal 4, which is 1/4. I get 4 over 4x is less than 8 over 4. I get x after the 4's cancel, and I get 2 after I simplify 8 over 4. So x is less than 2. Okay, on the dividing, I could, instead of multiplying by both sides by 1/4, I could divide both sides by 4. I still get 4 over 4x, and I still get 8 over 4, and x is less than 2. So whether I multiply by 1 over 4 or I divide by 4, I get the same result. And that was using a positive a. Now let's use a negative a. A is going to be a -4 this time. -4x is less than 8. So I want to get rid of a, and that's a -4. I'm going to multiply both sides by the reciprocal of -4, which is -1 over 4. When I do that, I get -4x over -4 on the left side. I get 8 over -4 on the right side. The -4's cancel. I get x on the left side, and I get -2 on the right side. But you'll notice I had this less than symbol originally, but since I'm dividing both sides, or rather multiplying both sides by a -1/4, I had to flip the inequality symbol. Same thing if I'm going to divide both sides by a -4. Okay? I'll get -4x over -4 on the left. I'll get 8 over -4 on the right. The -4's will cancel each other. I get -2 on the right. But again, I started out with that inequality symbol, and because I was dividing by a negative, I had to flip and create that inequality symbol. And the way you can prove that is by doing a check and saying, okay, take something that makes this true. Okay, take something that makes x is greater than -2 true. Well, 0, for example. 0 is greater than -2. Put it into the original equation, okay, and see if it works. Okay, so if I put 0 into the original equation, I get -4 times 0 is less than 8. And then I get 0 is less than 8. Yes, that's true. This is the exact same check right there, just done twice because it was the same result here, so it's the exact same check. So you'll see that the 0 is less than 8 is true, and so therefore this is true, and therefore we were correct in flipping the inequality symbol. Okay, last one is now going to practice it with a negative coefficient, the same thing we just did, but one more practice just to get used to it. Okay, so we have this equation, 60 minus 1.5x is less than or equal to 30. Ask yourself, is it in the right form? If it's not, in this case it isn't, put it in the right form. Okay, and that's important because of all these negatives and things. If you don't put it in the right form, you're more likely to lose a negative symbol. So get it in the right form first. Then get rid of b. b is 60. So we're going to add a -60 to both sides, the addition property of inequality. We're going to simplify, and after adding a -60 to both sides, we have -1.5x is less than -30. Now, we need to get rid of that a. And in this case, a is equal to -1.5. Okay? So we're going to divide both sides by -1.5, or consider it multiply both sides by 1 over -1.5. Okay, but in either case we're getting rid of a -a, so we had to flip the inequality symbol right there. And our answer becomes x is greater than or equal to 20. The 1.5's on the left-hand side cancel out, and -30 over -1.5 becomes 20. X is greater than or equal to 20. And this is how you'd graph it. You would show a solid dot at the 20 and a line going this way showing everything greater than and including 20. And then you do a check. You say, okay, step 1 of the check is to solve for the equality part of it, and step 2 is to check for the greater than part of the solution. So we put 20 in, because that's the equality part, into the original equation, and 60 minus 1.5 times 20 is less than or equal to 30. Yes, the left-hand side becomes 30, the right-hand side is 30, and 30 is equal to 30, so that checks. Put it in a second time with a number that makes the greater than part of the solution true, and I chose 30. 60 minus 1.5 times 30, the left-hand side becomes 15, the right-hand side stays 30, and is 15 less than or equal to 30? Yes, it is, so it's true, and we were correct to flip the inequality symbol. And that is lesson 3-7.